Hello. A few days back on Hacker News, I saw a post linking to an article called OnCAD, which compared OnShape, FreeCAD and SolveSpace by drawing a SolidWorks Model Mania 2001 challenge model. The links are in the description, and since I contribute to SolveSpace, full disclosure, I decided to draw this model and see how it goes for me. So here is the model. This is not a tutorial, so I will not explain my usage of SolveSpace in detail, but I will explain from time to time my thinking as I draw it. So let's start with a short reference sketch which gives us this basic shape. As I draw, you can see my keystrokes down here. So these two need to be perpendicular. This is 64. We know that this angle is 45 degrees. And what else? 146 from here to here. And this still has 1 degree of freedom, and this is this line segment, which is 32 plus 12 down here. As you can see, I can type formulas and they get calculated on the fly. Now this is fully constrained. This is good enough. Now let's switch to this view, make a new work plane. A rectangle at midpoint. Now this is 64, but I already have this 64, so I can just make these two equal length. Extrude it. And this is 20. Okay, back to this view, new sketch. I'll hide this extrusion in order not to have it interfere with me. And I'll start drawing this part here. I'll draw it slightly weirdly. You'll see why in a moment. Okay, now I can move this. This point is already on this line from the previous sketch. I can make these two parallel, and this needs to be perpendicular, or I can make these two parallel, doesn't matter. And this is 12. I think so. Yes, 12. So this is the same thickness as here. This needs to be horizontal, so this is still free to move. If you move too fast, sometimes you get this weird jumping around of the model. Just undo it. Now, why can this move? First, this distance here is not fixed. It's the distance from this center line to the edge, which is the same as the radius of this cylinder, so 64 over 2. Again, typing formulas. From here to here. Not that you cannot calculate that this is just 32, but this is convenient in general. Now there is still freedom because I haven't added the tangent arc here, and they do seem to have, yeah, they do seem to be concentric, so I constrain their centers together, and still 2 degrees of freedom because these arcs can move. This is R15, so 30. And the only remaining degree of freedom is here, doesn't really matter. Extrude this, two-sided, and make it, well, yeah, it is 64, but it's really, I could make this equal to this, because I know that, sorry, could make this line here equal to this line here. No. Yeah, I already have a constraint. Can make this line equal to this line, and it will just make it proper. Can hide it. Okay, I have a decent looking model. Now I want to make the cylinder shape here. It would be good if I have a reference line here, and it's easy to do this. All I have to do is add a datum point on here, and as I soon go back to the extrusion, you see that now I have a line here, which will help me. I want a new work plane, so let's do this. Cylinder 52, I think, yes. Extrude it. The height is 32 plus 12. The reason it's 32 plus 12 is because I started it from the back plane, and it's really 12 and 32 there. Yep. Good. One more work plane in the same on the same part. An arc. It's a little bit hard to catch the center of the arc, but yeah, there it is. Okay. In order to make this cut out the corners, I need to make this a shape. So I'll just put some lines here, completely random, and an extra circle for the hole. It's diameter 32, yes. Extrude this, two-sided, stretch it out and make it a difference. And now I have the cylinder shape. Good. Remaining thing, this edge here. So another work plane in this. Now, what to do? Link. Down to here. And then arc. This is tangent. way. Mm-hmm. Are they parallel? They are parallel. This is horizontal, this is tangent. What is this diameter? 55. Okay. There is a tangent arc here. And this tangent arc seems to be, okay, they have given here 26 as a thickness of this piece. Okay, I'll create a tangent arc. I'll make this. Okay, the distance from here to here. 26. Okay, let's show the solid model. Yeah, looks reasonable. My sketch has 8 degrees of freedom. The reason is all of this stuff can move around. And it's not too good to be able to move it around, because once I start constraining, I may have trouble with this. So I make a short line here, just a reference one, and constrain this to the midpoint of the line. This will guarantee me that this won't move around. And here I don't like this, so I'll make this and this parallel, just for the heck of it. Pull my constraint out there, and I'll make a delta distance. Distance, distance, distance. Yeah, this arc. Is strange. Probably this is concentric with the rest of them. I guess. Maybe not. No, it cannot be. So really the distance between these two needs to be 26. So I need one more constraint here between these two lines. Which should constrain it and leave 1 degree of freedom here, and perhaps 1 degree of freedom for this to move. So I'll constrain this just for the heck of it here. Not like that. And let's call this 20, doesn't really matter. Now I extrude this. There's a two-sided extrusion, and its thickness is never specified, but let's presume that it's the same. So the same as the thickness of this one. Can pick any line on this extrusion, whichever one I want. Let's say this one, and any line on here. Probably best to hide all and leave only this extrusion, and my reference sketch is visible. So now, not my reference sketch, but this sketch. Yeah. So I can make this equal to that, which will force it to 12 millimeters. We could double check by adding an actual dimension. It will be created as a reference dimension of 12, but it's not required. Hide everything, show the solid model. Yep, and I think this is the model. No, I'm missing two holes here. Okay, this is very easy to add in SolveSpace. Just go back to the sketch which defined this, and I can simply add two circles, make these 2 points symmetrical around the coordinate axis. The two circles are the same diameter, and their distance is 60. And it's an M6, so let's just call it 6, even though I'm obviously not going to model the threads on here. And it's 32 from the bottom. This is interesting. You could do midpoint, but really all I need to do is distance from here to here and call it 32. Just like in the model. And now if I go back, hide all, you can see that I have this beautiful model. Maybe save it. As you can see, I've done it before. Can hide the hidden lines, hide these, or make it look like a proper drawing with hidden line removal. As was mentioned in the review, SolveSpace does not have fillets as a function. However, otherwise it's pretty easy and straightforward to draw this model. And now, one last thing. There are actually two parts to this challenge. Phase 1, and then in phase 2 they ask us to basically change this angle to 55 degrees without seemingly changing anything else. So 55 degrees. What do I need to do? Go to my reference sketch, and change the angle. It's 55 degrees now. Go back. And it changed. That's all really. So I hope you enjoyed this video, and thanks for watching. And one thing I wanted to add, perhaps you've noticed that the circles look pretty rough. This is a configuration in SovleSpace, chord tolerance and piecewise linear segments. So I could make this 0.01 and then I'll have perfectly smooth circles. We can see also the triangle meshes that SolveSpace generates. Yeah. So this finally is everything I had. Have a good day and thanks for watching again.